For over 40 years, a quiet valley in central Norway has harbored an inexplicable secret. Deep within the Hessdalen Valley, mysterious glowing spheres of light hover, dance, and split apart in the pitch-black night. Sometimes these brilliant orbs zoom across the sky at hypersonic speeds before vanishing into thin air. Other times, they simply float silently for hours just above the treetops. In 1983, alarmed local residents reported seeing dozens of these strange lights every single week. Scientists quickly established a permanent monitoring station equipped with advanced radar, magnetometers, and cameras. They expected to find common atmospheric activity, perhaps ball lightning or temperature inversions. Instead, their instruments recorded data that challenged the very foundations of modern physics. The radar screens tracked solid reflective structures moving through the air at incredible speeds. Yet, the physical cameras pointed at the exact same coordinates captured absolutely nothing. How could a solid radar reflective object remain completely invisible to the human eye? This paradox left researchers standing in absolute disbelief in the freezing Norwegian winter. Their sensors documented physical energy signatures, but their eyes saw only empty space. The valley became a focal point of international scientific interest and deep speculation. What hidden power generates these self-sustaining glowing spheres in this remote Scandinavian region? Why do these phantom lights defy our conventional models of combustion and chemical reactions? Are we witnessing a brand new state of matter occurring naturally on Earth? The central dramatic question began to consume every researcher who visited the valley. They needed to understand the physical force behind these radar detecting glowing spheres. They wanted to know if this phenomenon could unlock new secrets of energy. The search for answers would lead them deep into the Earth, testing the limits of chemistry and electromagnetic theory. The silent valley held its secrets tight, but the sensors kept recording anomalous signals. Each night brought new sightings, and each sighting brought more questions than answers. The scientific community realized that this was not a simple mystery, but a portal to a new understanding of nature. Every observer felt the quiet tension of the valley, a landscape that seemed to watch them back. The mountains rose like silent guardians over a mystery that has lasted generations. Locals spoke of ancestral lights, but science demanded numbers and proof. The instruments recorded massive electromagnetic surges before each flash of light. These surges suggested a deep connection between the Earth and the sky, yet no one could pinpoint the exact source of this sudden electrical discharge. The valley itself seemed to act as a receiver for some unknown cosmic energy. We must look closer at the geology of this unique Norwegian landscape. The mystery deepened when researchers analyzed the first set of raw spectroscopic data. These light spheres were not mere reflections or optical illusions in the cold air. Spectrometers revealed a complex chemical signature, flashing with the distinct spectral lines of metal. Ionized gases within the glowing balls contained scandium, titanium, iron, and sodium. Finding these specific metallic elements floating in the atmosphere puzzled the scientific community. Scandium is a rare transition metal, highly concentrated in the valley's geological structures. How could solid ground metals suddenly transform into glowing, airborne plasma spheres? To find out, joint Norwegian and Italian teams launched the instrumented EMBLA expeditions. They deployed magnetometers, laser systems, and radio receivers across the valley floor. Their sensors recorded massive electromagnetic pulses accompanying every appearance of the lights. The lights behaved like coherent, self-organizing plasma formations operating under extreme energy. This data shifted the investigation from simple weather anomalies to advanced electromagnetism. Researchers documented how the lights could change color from bright white to intense blue, and then split into multiple independent spheres. These daughter spheres would hover side by side before merging back into a single unit. Such complex behavior is completely inconsistent with common combustion or burning gas clouds. Combustion processes expand and dissipate rapidly, but these spheres maintained their shape and size for hours. The EMBLA team recorded radio waves pulsing at low frequencies from the glowing objects. These radio signals indicated a powerful internal electrical current sustaining the plasma structure. The valley became a natural laboratory, revealing a phenomenon that occurred nowhere else on the planet. Scientists realized that they were observing a self-confining plasma system. This system could contain massive amounts of energy without collapsing. The discovery of these metallic spectral lines forced researchers to look deeper into the soil. They mapped the entire valley, cataloging every mineral deposit and water source. The geological survey revealed a landscape that was far from ordinary. The rocks beneath the valley floor were rich in mineral veins, forming complex electrical pathways. Abandoned mines from previous centuries dotted the hills, leaving behind open tunnels and exposed ore. Scientists wondered if these underground mineral networks were interacting with the atmosphere. They measured the electrical conductivity of the ground, finding highly anomalous readings near the river. The soil conductivity changed dramatically depending on the local moisture levels. Every rainstorm seemed to charge the valley, predisposing it for a nighttime light show. The researchers realized that the earth beneath them was not dead rock, but a dynamic, conducting system. They began to compile a massive database of geological and atmospheric correlations. This database would soon expose a giant electrical circuit hidden in plain sight. Then, a sudden experimental breakthrough shattered the boundaries of traditional atmospheric science. In 1998, scientists pointed a high-powered laser beam directly at a hovering sphere. Instantly, the light orb reacted by doubling its pulsation rate in perfect synchronization. When they turned the laser off, the sphere returned to its original rhythm. This direct reaction to human observation suggested a highly responsive electromagnetic structure. How could a natural plasma cloud interact so precisely with a focused light beam? The answer lies buried in the unique geological layout of the Hessdalen Valley. A mountain river, the Hesja, cuts directly through the center of the valley. One side of the river contains rocks rich in zinc and copper. The other side is dominated by massive deposits of iron and copper. When acidic water from old sulfur mines leaks into the river, it creates an electrolyte. The entire valley effectively functions as a colossal natural battery charging the air. Tectonic stress on the local quartz rocks generates additional piezoelectric currents. These subterranean currents flow upward, ionizing the atmospheric dust and gases. The resulting electrical potential difference between the ground and the atmosphere creates a conducting path. This path allows the natural battery to discharge its accumulated energy into the sky. The localized ionization of the air forms self-sustaining plasma structures, which we see as glowing spheres. This electrogeological battery model was the first to explain the constant source of energy. Yet, this model faced intense skepticism from physicists who studied plasma confinement. They argued that a simple battery current could not keep a plasma sphere stable. A plasma sphere in open air should dissolve in a fraction of a second. The fact that these lights lasted for hours remained an unresolved scientific paradox. Researchers continued to search for a secondary mechanism that could confine the plasma. They realized that the geology of the valley was only one part of the puzzle. The atmosphere itself had to play a role in stabilizing these glowing structures. The investigation was now caught between the earth and the air, seeking a unified explanation. They monitored the magnetic field variations, seeking patterns that matched the light's movements. Every fluctuation in the local magnetic field was carefully recorded and mapped. The data showed that the lights preferred to travel along specific geological faults. These fault lines acted as natural wires, guiding the electrical energy across the valley. The scientists realized that they were dealing with a complex, interconnected system. The valley was not just a static landscape, but an active electrical circuit. The mountain air, geological deposits, and flowing river worked together in harmony. This realization marked a major step forward. But the scientific debate was far from over. Competing theories began to emerge, challenging the geological battery model at its core. Despite the geobattery model, a fierce scientific debate divides researchers worldwide. Some physicists propose that the lights are clusters of macroscopic Coulomb crystals. This theory suggests that radon decay in the valley releases alpha particles. These particles ionize the air, forcing dust particles to group into glowing structures. These dusty plasma crystals could explain how the lights maintain a stable shape. However, rival geophysicists strongly reject this plasma crystal model as insufficient. They argue that ionized dust cannot account for the hypersonic acceleration of the lights. A dust cloud simply cannot turn 90 degrees at thousands of miles per hour. Instead, they propose that scandium dust clouds are combusting in the air. Yet, combustion cannot explain why the lights reflect radar waves so strongly. This paradox has left the scientific community locked in an intellectual stalemate. The lights continue to hover at the intersection of geology and quantum mechanics. Some scientists suggest that the lights represent a form of ball lightning, but a ball lightning event is extremely brief. The Hessdalen lights, by contrast, can persist for up to 2 hours without fading. Other researchers have proposed that the lights are triggered by cosmic rays interacting with the local magnetic fields. This model suggests that high-energy particles from space are focused by the valley's magnetic anomalies. The incoming particles ionize the air, creating a localized glow that mimics a plasma sphere. Yet, this theory fails to explain the presence of metallic elements in the spectrum. The presence of scandium and titanium remains a hard geological fact that cannot be ignored. The debate has become a classic scientific conflict between atmospheric physicists and geologists. Each side holds a piece of the truth, but neither can explain the whole phenomenon. The valley remains a silent witness to this ongoing intellectual battle, holding its secrets close. The lights continue to appear, challenging every theory that attempts to define them. No single theory has been able to reconcile the radar data with the visual observations. The conflict has forced scientists to reconsider their basic assumptions about plasma stability in the open atmosphere. They have proposed new, hybrid models that combine geology with advanced physics. These hybrid models suggest that tectonic activity acts as the primary trigger, while atmospheric conditions stabilize the resulting lights. Yet, proving this connection requires more precise measurements than currently available. The researchers are left with a wealth of data but no clear consensus. Every new expedition brings more sophisticated instruments, but the core mystery remains unsolved. The scientific community continues to argue over the true nature of these glowing orbs. Meanwhile, the lights keep flashing in the cold night, indifferent to human theories. We finally stand on the verge of a revolutionary cosmic discovery. The Hessdalen lights are not isolated anomalies, but natural laboratories of advanced energy. They represent a rare confluence of geological batteries, tectonic stress, and atmospheric plasma. By studying these glowing spheres, we may unlock wireless energy transmission systems. This natural phenomenon proves that the Earth can generate and sustain coherent plasma structures. As we look at the quiet valley, we must expand our scientific horizons. Similar electrogeological batteries could be glowing across the surface of Mars or Titan. Perhaps these alien lights are already waiting for our future robotic explorers. We started with invisible radar echoes in a silent Norwegian valley. Now we hold a key to understanding energy generation across the cosmos. What other secrets are charging beneath our feet, waiting to ignite the sky? Share your thoughts on this mystery and subscribe to join our journey. The lessons of Hessdalen remind us that nature is far more complex than our current scientific textbooks suggest. The valley functions as a macro-scale plasma battery, demonstrating how geology and atmosphere can merge into a single energy system. If we can replicate this process, we might create clean, self-confining power sources on a massive scale. The mysterious lights are not just an unsolved puzzle, but a blueprint for future energy technology. Scientists are now designing laboratory experiments to simulate the valley's geological battery conditions. They hope to spark miniature Hessdalen lights in controlled environments, unlocking the secrets of plasma confinement. This research could redefine our approach to fusion energy and power grids. The silent Norwegian valley has given us a glimpse of a technology that is millions of years ahead of our own. We must continue to watch the skies and listen to the Earth, for the next breakthrough is already charging. The glowing spheres of Hessdalen will continue to shine, guiding our way toward a deeper understanding of the universe. As we venture further into space, we will encounter environments far more extreme than this valley. The electrostatic storms of Mars and the liquid methane lakes of Titan may host similar electric phenomena. By understanding Hessdalen, we prepare ourselves for the strange worlds that lie ahead. The scientific journey that began in a small Norwegian valley has expanded to include the entire solar system. We are reminded that the line between mystery and discovery is defined only by our willingness to explore. The Earth is constantly speaking to us in a language of electric currents and glowing lights. We only need the courage to listen, to measure, and to learn. The lights of Hessdalen remain a shining beacon of this eternal scientific quest.